Okay, so yesterday we left off here just before you left for lunch. What we did yesterday was, in order to prove that g prime minus 2 does not exist, what we did yesterday was we calculated the left and the right derivative. We started off with this line, which led me to this line, and we split into two parts, all because modulus of x plus 2 is defined differently on the left and on the right of minus 2. For that reason, we calculated the limit on the left and on the right separately, and we verified that these two limits are not the same. And because these two limits are not the same, we conclude that this derivative does not exist. And that was our example 5b. Right? Okay, moving on, we will have more examples. Okay, let's see another one. Okay, let's see another one. You are given a function fx. Maybe it is good that you draw a sketch of this graph. Bearing in mind that this is a piecewise function, it is defined differently on the left and on the right of x equals to 1. So now you can draw the graph. Bearing in mind that the demarcation happens at x equals to 1. When it's more than or equals to 1, when it's more than or equals to 1, right? We are told that it is x cubed. So more than or equals to 1, it is the x cubed graph. So x cubed.
Can I run back to boarding to take my notes?
Sure. You don't have to run, you don't have to run. Think we just walk briskly.
You come back, you're going to sleep. So
Yeah, right. Thank you for that. Oh, destroyer. Yeah. Okay, so there's the part that's x cubed. Then there's this other part, There's the other part where it cuts at minus 2, and that part is actually a straight line, which is 3x minus 2. So what happened here on this graph is, looking at this portion here, right? Look at this portion here, there's actually a sharp, maybe, I am not sure, maybe a sharp turn, maybe, we do not know, we got to verify this, okay? So we're going to do our calculation to check things out. Now, sharp, okay? I am really not too sure about this corner. We will find out soon, okay? And then we can, after that, polish out our graph, okay? Now, to start off with f prime 1, we have learned, okay, in case Yu Tong is a bit upset, she missed the starting of chapter 2, not to worry. It is simply like this. It is simply like this. So the starting line of f prime 1 is equals to this limit. And then we all know that f1 based on the definition that f1 is equals to 1 cubed, which is therefore 1. So now we are here. But because fx is defined differently on the left and on the right of 1, we will now have to actually find this limit in 2 steps. Yu Tong, what is the first step? Yeah, see, she knows. Like, on the way back from Malaysia, she was reading the math notes, I guess. Okay, from the left side, right? From the left side, it is actually 3x minus 2. And this evaluates to 3. on the right side. When it's approaching 1 from the right, you will have x cubed. And for this one, right, we can actually factorize the numerator. Okay, let's test out again. Let's test out Yutong again. Yutong, how do you factorize x cubed minus 1?
X minus 1.
And what else?
X squared plus.
Right?
Plus 1.
Right. So she said this. I told you she learned math on the way back.
Thank you.
Yep. Hey, by the way, tomorrow is the grade task 1, you know. Tomorrow. Not coming to school, I'm just afraid that everyone gets full marks, though. Then I look bad. Because if everyone gets full marks, right? We look bad. It means our test is too easy.
No, that's good. It's fine. Okay, fine.
Anyway, you got to work hard on it.
No, it's because of teachers. No, it's because you are good.
Okay. Because of 1 and 2, I therefore declare that this is 3 by 1 and 2. So therefore, in this question, the limit on left and right are the same, and therefore f prime 1 is equals to 3. So now we have to polish up the graph a little bit. You know, our graph is a little bit wrong because it looks like there's a sharp turn here. I'm going to erase. So the good thing about using technology, you know, I can always draw and redraw. You know. So therefore, I want to encourage all of you to embark on the digital age. You know, embark on it with a lot of confidence. You're not alone. You have me. You have everybody else. So over here, I have now redrawn it to be a smooth curve. It joins up nicely. Because we have proven that the gradient there exists, that tells me that on the left and on the right, at 1, they should have the same gradient, you know, so they should join up nicely. Okay? And then that brings us to this 4 boxes. In these 4 boxes, you are asked to sketch graphs which is continuous and differential. And let me roll back a bit in case you are still copying. Okay, anyone still writing? Is it a baseball cap? Hide the light. No, it's not okay. That's right. Okay, let's draw a curve which is both continuous and differentiable. That's easy. You draw a curve that is smooth. Hey, thank you for coming. Hey. What happened? Okay. Yeah, better be late than never, isn't it? I learned this when I was a policeman, you know. My teammates would tell me, say, better be late than never. Because you rush, right? You rush in order to be late, then you get into accident, it worse, isn't it? So he tells me, better late than dead. Okay, yeah, that's a very strong one. Yeah. So if you're late, right? If you're late, just late like that. Maybe it's one of those days. We can be more forgiving if it's just a one-off thing. Okay, continuous and not differentiable. We have learned to see that if you have a sharp corner like this, if you have a sharp corner that's like this, it is continuous but not differentiable. Right? When you have sharp corners is given a name. Is cusp. C-U-S-P, cusp. C-U-S-P. Not continuous and not differentiable. So easy example will be like this. Say maybe like that. Okay, not continuous and not differentiable. And now for the last one. Can we draw a graph that is not continuous but differentiable? What? Can we draw a graph that is not continuous but okay, not continuous but differentiable, is it? Like that, right? Like that, is it? Like that, okay. So let's look at this example. Someone says, say maybe you get this A. Someone says this function, right, is not continuous but differentiable. Okay, any objections from the floor? So now we have a contention here. Chen Hui, right? Chen Hui suggesting that we want to look at a graph that's like this. It is not continuous. Okay, assuming that this value is B. Okay, Hui, you agree not? Okay, you're talking about this graph, right?
What?
Hui is your name, what?
Hui.
It's not. Your name is not Hui.
It's Chong Hui.
No, Chen is the middle name, man.
What?
Hui.
The name's Hui Chong Hui.
Okay, let's see again. Let's see. Hao Wen for coming in so not so punctual. Not him. On here it says. Oh no, not Hao Wen. Okay, Xiao. Jun Xiao. Jun in the middle name is Xiao. Can you kindly tell us?
It's actually
Blackpink, the artist Blackpink. We have an artist, a world-renowned artist. Okay, let me hear from you. What's the definition of f prime a? The definition. The limit what? Limit when x goes towards a of f of x minus. Okay, Chen Hui, but because FA is not defined, yeah, you can't, you can't.
Oh no! Oh my god! Wait.
So it can't, it can't. Okay, so this example, well, is a good event, yes.
But you can do the limit on FA, but that's not possible.
How do you define that?
Okay, so Chen has another suggestion. She says like that and like this. Is it?
That's what we did.
Maybe this is 2, maybe this is 3, maybe this is 5. Shall we try?
We did it just now, it's not different.
Okay, now you owe me something. Can you give me a diagram which is not continuous but okay, Chen Hui. Yes, Aditi. Never mind. I'm right here, is it? Never mind. Okay. It's true, no? Never mind. You cannot draw it. 没有, don't have. Don't have.
What if you define FA as some other point?
Okay. So there's another suggestion. Okay, what do you, is it like this? Yu Tong?
Yeah, but you define FA something.
The one on the left.
This one is it? Okay, here like that.
Yeah.
C.
Okay, use
Right.
D. Use D. C by C.
Or D. Okay, so maybe let's put numbers, make it easier for us to imagine. Is it okay? Okay, no need put number. Okay, she doesn't want number. Okay, so let's try. Let's try again. Let's try.
你就信点快乐。
Okay. Then limit x goes towards a. Okay. So she say is f of x minus d over x minus a. Now, class, do you agree with me that as x approaches a, this number, right? This number is never close to d, and therefore this numerator will not be 0. The numerator will not be 0. Agree with me? No matter what, because it is never d, right? Fx is never equals to d because as x approaches a, based on the diagram, it actually approaches what? B, right? So on the numerator is d minus d. But right, thank you for saying up. So because there's 0 on the denominator, the thing will explode, and therefore, for the reason, okay, thank you for this example. It doesn't work.
Answer is wrong.
No, the answer therefore is never mind.
Yeah.
Don't have.
Oh my god.
Never mind, don't have. 没有.
HB.
The answer is 没有. Don't have. Never mind. Don't draw. Will not happen. Impossible. Never happen. You know, in Malay, tada. In Tamil, what do you mean? Tada means don't have, right? In Malay, your Malay friend can check. Oh, don't have. Okay. Tamil is what? What is it? Ile. Okay, now I learned something. Ile. 没有 don't have. Okay, so everybody don't have. Okay, right, it's okay.
Only two.
1 to 3 years.
Yeah, I'll come back. I'll come back.
Try so hard, I'm going to take a little okay.
So, from this example, right, you begin to realize something, no? That actually, continuity is a necessary condition for differentiability. You need continuity first, without which differentiability will not happen. But very careful, no? I said necessary. You know what I mean? You need continuity before we can talk about differentiability, right? It is a necessary condition. So we are going to move on to actually, okay, before you go on to prove that result that is a necessary condition, I want to entertain you with this nice graph. I got it some years back, of course, from the internet. If you look in this graph, okay, in this graph, right? This graph tells you that the man who smokes and the man who doesn't. It says if you never smoke, right? It means never puff. Okay. Then as you age, right? As you age, you see horizontally is the age of the person. It says if you are a non-smoker, when you are at this age, right, the chance that you will actually survive is this much. But if you smoke, the chance of you surviving is lower. So in the long and short, smoking has a tendency of shortening your lifespan. But very careful, no. Don't read this and jump to the conclusion that all smokers will die earlier than you. It's not the case, This is on average, I know of at least one world leader who lived to a good old age, Mr. Deng Xiaoping. He lived up to the age of 92. He died in 1997, just before Hong Kong returned back to Chinese rule. Just before. He wanted to live long enough to see the return of Hong Kong to China, but he didn't mention. So I remember that he died good old age. Yeah. He smoked a lot. He was a chain smoker. He was a chain smoker. Chain. I was a police investigator. Inside the interrogation room, you know what's the interrogation room? The room that you talk nicely to the accused person, I know. Nicely. A lot of people inside the room smoke, I can't take it, Yeah. I will step up after maybe 30 seconds, Yeah. Because you got to smoke to talk to the criminal. Not that I smoke, I didn't have to do that. I have my good detective, they are the interrogators who will actually do it for me. And they always start off with a nice person first. He will offer, do you want to smoke? You want a cigarette? Okay, then the guy start to lit out the things. Then nice talk. Don't get anything from the person. Remove the cigarette. Okay, anyway, that was my part of the story when I was an NS man. Okay, back to this graph. It's interesting to note for the case of women, it says if you don't smoke, right? You compare to men, right? Women has a better survival rate than men, Sadly so, right? Okay. But what I want to highlight to you is, in this graph, it tells you that women who smoke, right, when you reach a certain age, right, their survival drops very quickly, Their chance of survival drops very quickly. It's a very fascinating thing, The gradient is very steeply negative. So the message up there is, don't smoke,
Yes.
Among my friends, I say for yourself, I don't think you will encounter smokers probably in your lifetime among your good friends. I'm not talking about acquaintances, okay? You'll be like this one, you'll be like this. Same for me. My good friends, my circle of friends, they all are non-smokers. It's like that, right? So you don't smoke, chances are that your friends are also non-smokers. Okay, now back to the more important thing. What is it again?
Yes.
Yeah, I can tell you won't. No, I'm sure you won't. Yeah. Now we come to a very important aspect of differentiability and continuity. Plus, continuity is a necessary condition, which means without continuity, you cannot talk about differentiability. Which also means, if I say to you that something is differentiable at a point A, it will definitely be continuous at a point A. So now we are going to start proving this. If f is differentiable, which means this exists, and this means what? This means limit x tends towards a of fx. Right. So when you say is differentiable at a, it means this one exists. And then you want to prove that it is continuous at a, which means you want to prove that this is true. Okay, don't prove this, do proof. Okay? Okay, let us start off this way, okay? Are you ready? Okay, we want to start off with this line. Okay. To do this proof, right? To do this proof, you are going to do in 2 steps. We are going to do step 1, we are going to start off with this line. And later on in step 2, we are going to start off with this other line. Okay, this is our aim of step 2. For step 1, I want you to know that we intend to show that eventually, okay, this is what I intend to do. Okay, right, and we are going to use step 1 result to prove the step 2 conclusion. Are you all ready?
Yes.
Okay, step 1. So let's start. Limit x tends towards a. We are going to do this. Why do I do this? It's because I know something about this. What do I know? I know that this limit exists. How do I know? Because it's given in the condition. And because this limit exists, we have learned before, I can then break it up into the product of the two limits. Why can I do so? Because I know that both limits exist. Right? Kaita, right? Kaita, tell me why should this product be 0 in the end? You were saying that what? You're saying that this one is how much? How much is this? It is 0, right? And how about this? This one exists. Exists means what? Exists means it has a finite value. And because it exists and has some finite value, together with that 0, therefore it is 0. Right? This is what you're trying to say, right, Kaita?
Yes.
Just say yes. Okay. Right. Then the next stage is to prove. To prove the limit of fx as x tends to a is fa, we are going to start off with this line. Okay, we're going to start off with this line, and then say that this is equal to limit x tends towards a and this gives you. Why can I break the two limits? Because I've proven earlier that this first limit exists, and we have even proven that this limit exists and is equal to a. Fa is a finite value. Therefore, the limit of fa as x goes to a is still fa. Then because remember we have proven that this is 0 right now. So therefore it's fa. So the red color proof therefore implies that f is continuous at x equals to a. So what we have proven here is whenever something is differentiable there, it will be continuous at the same point. And once again, it is a necessary condition, but not a sufficient condition, you know. What does it mean by not a sufficient condition? It means even if a function is continuous, it doesn't guarantee that it is differentiable. Be very careful, because earlier on we have proven, right? We have drawn diagrams, yeah, the V shape, yeah, the V shape, right? The V shape graph tells us that it can be continuous but not differentiable. Okay. Let's have Tae-yun, fill in the blank. Tae-yun. Right, you can multitask, are not bad. Okay. If I could like, it'd be nice to make a lesson like a concert, you know. Yeah, then make a lesson like a concert. Everybody very happy, very high, and then learn very quickly. Blackpink, you have a Blackpink performer there. Okay. Example 7. Okay, example 7. Money, right? You want to tell us how you would do this question? How would you want to prove that this is not differentiable? F is not differential x. At x equals to 0 because f is not in English very funny, no? After you use the word because, the next one you use is since. You cannot say because. Right, is it correct? Yeah. I cannot master a linguistic thing, because there are always a lot of exceptions,
Since.
There are a lot of exceptions to, for example, how do you pronounce this word?
Metamorphosis.
For you.
How do you pronounce this word?
For you.
Taylor Swift. Where? Wagyu.
So language is kind of how to master, because there are too many exceptions, He is, she is, but you are. You know what I mean? Language,
We'll be right back.
they always create rules to confuse. Not like math. Never, never do such thing. Math is always like. Okay, since what? Since the limit as x tends towards 0 minus is equals to 1 is not equals to, which is the limit when x tends towards 0 plus. Did I make mistake? See me. Chen Hui, you have something to say? Just discuss. Okay, nothing. Okay, for a long time since you were very young, because all of you were very good with primary school math, and you were very happy about it. And in fact, a lot of your teachers, tutor, enrichment center people will tell you, you know to memorize on math is all about understanding. Class, lo and behold, I want you to know, this is how true, how true. Inevitably, you need to have some memory work for math, Yeah. I'll go back. I go back. I'll go back. Just a second. What? Okay. Let me roll back to do this one. Aditi says she's not happy with this. She says she wants to start off with the definition of differentiation and proof from there. So Aditi says, Mr. Lim, let's start with this line. And this means then from here, right, I heard people saying already, it is split up into left and right again. And then Aditi, when you do this right, you will be able to prove that they differ. Yeah, therefore they differ, isn't it? And therefore it is not differentiable. You can do that also, but if you do this right, you are not making use of the earlier result. That's all, but it's okay.
On the second line.
What do you see? Right. Okay. So it is just like that. So you just have to prove that these two limits do not tally. Okay. So I was telling you, that actually in math, just like many other subjects, you need some memory work. I'm not sure at this point in time. Do you still remember? There's a song, is no song, it's very old song, Maybe your
1 over root of 1 minus x squared. Just a negative of whatever's up there.
Oh, not bad, no. Ryan is the guy who remembers things. Good memory.
Oh, Ryan, the guy who won the stuff.
1 over 1 plus x squared.
No, 1 over 1 plus
1 over 1 plus x squared.
You have to memorize, no? For the A level exam, they are given a formal booklet where they don't give you this side, but they give you this side. Yeah. Let me just test out again. Trigo special angles. Are you familiar with it? You must memorize all those trigo special angles also. You must also remember the standard curves. You know what I mean? Yeah, it helps a lot. All the standard curves, Okay, now the name of this guy appears.
Leibniz.
I'm not sure is it pronounced that way because it's not an English name.
Leibniz.
Maybe some people who know German. Okay. Then the famous 3 rules: the chain, the product, and the quotient rules. Now we are going back to basic. I'd like you to read this example, and I'm going to ask you a question. You read this example, and I want to highlight something to you. Some more. Don't you do now?
No, but I need to draw one.
Then
I
draw.
want to draw it online.
Then draw one.
I don't have.
Take it again.
No, it's like out of the
You got this C. Okay, I'm gonna charge it for you. Okay, anyway, you want to realize after reading this example that chain rule is actually differentiation by substitution method.
Oh,
You realize that? Yeah.
Oh.
Right. Why do you have the notes with you? Your notes. Oh, you didn't ask her to get for you just now. Okay. Oh, different cluster, is it? Okay.
Yeah. No, I think it's
I think they are the same shit.
No, you could just ask some of the office staff to go in the room get for you. Then she can bring it. Anyway, it's okay. It's recorded for you, no money. Oh, you wrote down, okay. So you want to realize that chain rule is what I just told you. Can you now try this question? I want you to know that written this manner, it means this, it means this. It actually means this. The composition of FG. Can you all try this question now? You want to find H prime 1. Oops. So maybe you want to find H prime X first, maybe. You don't have to, but maybe a good choice to do this first. To differentiate a composition, you apply the chain rule, which says you do from the outermost, then to the innermost. Chain rule is like onion, when you eat an onion,
Meaning like layer.
yeah, layer by layer, that's right.
Oh,
Yeah.
I love raw onions.
Blue onions,
Raw.
or raw onions.
Yeah, oh my God.
Why?
Cause what? Use flavor.
Man.
Just say hi, boy.
I am surprised to hear that,
Wait, you guys like raw onion?
Man scrolling.
Who over here takes raw fish, the sashimi? Sashimi.
Yeah, pastas.
I don't dare, I don't dare. I'm just.
But it tastes very nice.
Really?
It tastes like the ocean.
Man.
It is interesting that people like raw, raw stuff. Personally, I don't dare.
Is it shut down?
Okay, example 9.
Can you do your
Okay, let's do example 9. Okay, Ethan, example 9. Do you know how to do?
night early color?
你会吗 Okay, Ethan, give you a chance to demo.
等一下子我的头脑是空的。
Okay, okay, Steven.
What? What, right?
Steven.
The name is.
Next year.
Oh, it's there.
It is.
Did it, is it? Who did it?
Here did it.
Yeah.
I just do the first part.
Finish it.
No lah, must save some for like alcohol.
1 kill.
Save some for alcohol. Let me think. Oh, I know that.
So I can do the other one.
Give me 30 seconds.
Sure.
Oh,
Right.
let's not type.
Times two.
Brilliant! You did
But
it!
then they say in terms of what? What's so weird? Yeah, that's not like. Oh! Wait, no. Yeah.
Okay, Ethan, march forward.
好的。
I sent out to you through the class WhatsApp the so-called in-class practice question, exercises. we will discuss tomorrow before the GT. So in case you have things to raise, you can raise up tomorrow before the GT. The one I WhatsApp to you, to your class, the in-class exercises 1 and 2.
Or you can just
Yup. It's in the class WhatsApp, you know. Almost correct. Almost.
You're missing something.
You're missing something.
Right. Okay.
Never change properly.
Wait. La ba 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 ba. Okay, times whatever lah. Times something inside the 2x.
Right. Times the 2x.
Yeah, times the 2x whatever lah. Same thing.
Oh, right.
Okay, that's example 9.
Different shape.
Oi, what's his name I see? Steven.
Okay, are you ready? Can you press on? Okay, let's roll back.
Yes, go.
That's why it's good to go digital for all your learning materials though. Maybe from chapter 3 onwards, shall this class take on this challenge to go fully digital. You have a lot of advantages. You just get something that you can write on the PDF file. I'll send you the PDF file and then just write on the PDF file. Even if your PLDs issued to you last time don't work anymore, I'm sure you got other devices that you can use to write on, you know. Right? Okay, anyway, next chapter I'll just send a PDF, so for those who like it, you know, because you don't have to bring notes to class anymore. You know what I mean?
Oh my.
Okay, class. Why do you think this word example is like that? Why do you think it's true? To see.
Then do it. Then is in F4. Then X minus 4.
Right. To see this, right? To see this, you want to actually look at this sentence. The differentiation of this function evaluated at x equals to 4, right? By definition, do you remember what's the definition of this? It is the limit as x goes towards 4 of fx minus f of 4 over x minus 4. And you realize immediately that this one is the same as this. That is why, and now you apply the formula list. The formula list that you have, you now differentiate, right? You now differentiate square root x, and then upon differentiating and putting x as 4, you get a quarter. You want to realize that class, it is demonstrating to you another way to find limits. Previously in chapter 1, let's recap again. Let's go around the room starting from, name me one way you will work out limits. You just have to plug it in if all things work. Next way to find limits that you learned chapter 1. What is it? You maybe have to do some factorization and do some cancellation. Factorization, then that one, you multiply by the conjugate. Like conjugate. Sorry, I didn't hear you. The fourth one, give a method. We have the squeeze theorem, that's right. And then another one, we use an x over sine x to manage limits that involve this kind of function, right? Okay, so we have learned quite a few methods in chapter 1, and in chapter 2 class, you are seeing yet another one.
What? Oh my god.
There's another one, another method in chapter 2 right behind. You already more or less have heard of before, L'Hopital. In chapter 3, there's yet another one. So I want you to look up now that along the way, you picked up more methods to solve limits. Okay, there'll be some more down the road. Okay. Now, can you try example 10? Of course, you say, Mr. Lim, don't be a fool. No, this is immediate one. Can you pretend that you do not know, and you can try to use?
This one, I don't know how to do.
You're for Hollywood, lah.
Yes.
Has anyone been to Hollywood? Have you been at least near enough, like it? I visited the place, lah. I visited the place.
Watching the movie.
Yeah.
Moving
Nice. Nice to be there. Okay, in any case, you want to be able to see that this one relates to a derivative. This one relates to the derivative of sine theta and evaluated at theta equals to 0. Why is that so? No? Why is that so? Yeah, because remember, this one by definition is right. And because of this, we now can just differentiate the sign. And the whole world knows that cos 0 is
1. Huh?
Wait. Wait, when do you get it?
Oh.
Very easy. What's the definition?
okay.
Oh.
Okay, that's example 10. Okay. Now we want to actually evaluate the following limits. Okay, part A. You. Yes, Chen Hui, you got something to say? Okay, 2 ln x over okay, to do this one, right? To do this one, limit x goes towards 1. There are different ways of going about it, you know. One way is to see this as like that, and then like this, and then we know that the limits of both functions exist. This gives you 2 over, and this gives you f. Okay, this gives you the derivative of ln x evaluated at x equals to 1.
Yes, I
Brother, where you are? Not angry.
Damn it.
Thank you. Huh? I was kidding. Okay. You could have potentially done it differently. No? Okay, for those who want to actually do it differently, some people do it like this. And then this gives you a limit y tends to 1, limit of y minus 1. You know why? You're just replacing the actually this ought to be root y lah. But for root y to be turning towards 1 is the same as y going towards 1. You know what I mean? You're just you're just replacing the x square with y. Wait, let me erase. Yeah, let me erase. If you now do this, no, you now do this. Let y be x square. You know what I mean?
But Mr. Liu, couldn't your x be going to negative 1 so when you do that?
Huh?
Because if your y is x squared, then y can be, no, then x can be plus or minus square root of 1.
Okay, you have to impose a condition. The x must be positive.
So how do you account for it?
Because your x go towards 1, isn't it? So if x go towards 1, all the x values are positive. See?
No, but how do you account for like, okay,
Okay. RTT says, Mr. Lim, I therefore should say that x is equals to like this. But this is refuted because if you are dealing with this, if you're dealing with x approaching 1, right? These x values, they have to be positive. Approaching 1, man.
I get it, but when you say y equals x squared, then like how do you make sure that you're not like counting x to negative 1?
You impose the condition that y must be positive. You know what I mean? Okay, maybe this method is too controversial, too much to confuse people. Maybe let's do the good old ways. You see, technology is very good, right? I can just erase at my will. I just erase. I can add colors. It's very nice. Okay, maybe let's take 2 minutes break.
Yay!
So let Zheng Heng, is it Zheng Hong to have some breather. Zheng Hong can get some drink, walk around, sing a song. Okay, let's pause. Did I record or not? I did. Okay. No. I'm sure. For the second question. Really? Okay, just nice. The class will be just nice. I think it'll be just nice. Okay. So for part B, how do you do part B? You must relate part B to a derivative. What will it be? It will be the differentiation of
X to the 7.
x evaluated at x. Okay, shh. I want the whole class to echo together. Huh? 1, 2, go.
X equals half.
Okay, it's half. Good. Okay. So this gives you in the end 7 over
64.
right.
Then what is this?
Okay. Then for for the case of the part C, right? For part C, now imagine if I say the integration of cos of t square. If I call this one g t plus a constant. Good task. Right. If I define the integration of this to be like that, then the numerator would be what?
3.
The numerator would therefore be g of over 有没有
Oh.
Chris,
G. Oh.
if I say right, then this therefore will become the derivative of gx evaluated at x equals to right now. Given that this is the thinking, tell me again, what is the differentiation of gx? Shh. Let's hear from Rayson. What do you think is the differentiation of gx? You're right. It's cos again. Cos x squared, right? And therefore, nice. It looks hard, but actually, we can define gravity. Apparently, my daughter likes to watch those auditions that fail, you know. She finds it very funny to see how people perform so badly on stage. And she laugh and laugh over those performers, you know. So she finds it amusing. Okay, still cupping? Okay, I can slow down. I thought you're doing your... Wow, Tingwei, the multitasking girl. She can do math and what subject? 10 horns at the same time. Okay.
Imagine taking models.
Okay, still copying. Sorry. You can't see Tingwei.
It's fine, I can see from here.
A few moments later. Oh my god, you're so lucky.
Jethro is quiet today because he's always quiet. Okay, I trigger it. Okay, anyway, let's come back to math on inverse functions. The question is like this, I know. We are trying to learn how to differentiate the inverse function. Okay, we are trying to learn how we differentiate inverse function. Now, the way to go about it is like this now. By the way, another way of writing this symbol is to write as like that.
Oh.
To learn how to differentiate inverse function, this section of the notes try to say a lot. But maybe we want to cut short by starting off with the blue color. Zhen Hong, do you see the blue color?
That's because he hasn't drawn it yet.
Because I'm not written it yet, Zhen Hong. Right.
Same trick as last time.
Yeah, same trick last time. Do you agree? Do you agree? Now you differentiate both sides. On the left hand side, Steven, what is left hand side? If you differentiate the left hand side, what do you get? I did.
Where is the
Left hand side.
The blue one? Blue one? Yeah, what about it?
Differentiate this portion.
Oh, yeah. Differentiate now.
Becomes what? F prime of
Oh, that one. Yeah, correct.
times what?
Times that one.
The inverse prime
Yeah,
x
Equals to?
Oh.
Equals to? Therefore,
1, right?
But the real one.
so the whole section or the whole page is trying to tell you these 3 steps. But it's too elaborate, it's too elaborate, and I thought it can be confusing, I therefore have helped you to shorten it with just the blue plus the green. Blue plus the green gives you what? Okay, so we're going to say the purple, okay? I have shortened it to be just the purple. Brown, man? I thought it's purple, I think it's purple.
Yeah.
Blue and green, I think it's purple.
Yeah,
Purple is blue and red.
Huh?
Purple is blue and red.
Blue and red, okay, sorry. I get corrected, Blue and green gives you what?
Cyan or turquoise or something like that.
Red, we have red.
Yeah, correct.
Blue and green is red.
Yes.
Blue plus green is like cyan or turquoise or something.
Okay. Anyway, I hope you understand the blue and green color. Okay, so this whole section of the page is to tell you that thinking. Okay? And this graph here is to show you again that the function f and f inverse are mirror reflection. And this section of the graph is an attempt to explain to you why it should be like this. You know what I mean? Why it should be like this geometrically. But I think it can be quite hard, for you to try to imagine what's going on there. Martin, why do you shake your head, Martin? Martin. Okay.
No.
Hey, I don't see his name on my name list. What's his name?
Oh, they moved that shirt.
Oh, he was there online.
Oh, Min. Oh, no, not Min. Viresh. Okay, Viresh. Okay. It's called Viresh. Okay. Alright, now can you try this number 11? Everyone try question 11. knowing this green color. The green color will help you with 11.
But if you don't bring this, you don't bring the one.
How come your notes for this thing?
That's my TLC script.
Oh. Number 11. How do you do 11? Using the green color, we will say that the derivative of the inverse at 8 is equals to 1 over f prime of can you tell me, Viresh, what is f inverse 8 equals to in this case? F inverse 8. How much? Look at this one. This point tells you that f of 1 is 8. So therefore f inverse 8 is 1.
Can you just find the inverse function from 9 to 10?
This is not the function fx, no?
Oh. Oh, it's the function.
And then, how do we do this? What is f prime of 1? F prime 1 is 5. Because we know that the gradient, right? The gradient of the tangent, in this case, is 5. Why is that so? No, because the graph is like that. This is the point 1, 8. And then the line in question is here, whose equation is 5x plus 3. What is after my class? How long is the recess? 30 minutes. Make sure we are there earlier than others, no? Are you hungry?
Yes.
Okay. Maybe we just do one question and then I dismiss the class, Shai?
Yay!
Okay. At your own desk, you want to write down the definition of f prime.
Right, answer.
If you can write down this line correctly, not bad, no, it means you have achieved a lot.
I achieve a lot.
And then you can give yourself 2 taps on the shoulder. This becomes what? F of the division line.
That looks like a blank from that because of the rest of the task.
F8 plus A minus FA over 8. Oh wait, right. Oh my god, I keep getting confused.
But because number 2 is too easy, you know. Might as well. Might as well, right? Might as well. Okay, I won't push my luck too much. I'm afraid later on you'll scratch my car.
What?
When students get too upset with the teacher, one of the revenge they'll do is to scratch the teacher's car. Our kappa is Canberra, tell first game. Okay, the one that is marked principal's lock. Okay, I think I will end my lesson here so that you have a you have an advantage to be in the canteen earlier than the rest.